Hey, what's up and welcome back. Just a couple things here. We are heading towards the OSTP, the Oklahoma School Testing Program, OSTP, coming up for us on the 12th, if nothing changes. It is scheduled for April 12th. Let's see. There we go. 4/12. That is when we have it scheduled. Now, I have a link to this parent student teacher guide on my website right here. OSTP for grade 7, OSTP for grade 8. And that will get you to the blueprint. Then you can see, okay, this is for grade 8. For numbers and operations, we got 9 questions. And you can just look through it. Algebraic reasoning and algebra 23. So the majority of that test is going to be over algebraic reasoning and algebra. 10 questions over geometry and measurement, and 8 over data and probability for 50 total. For 7th grade, the breakdown looks like this. Numbers and operations, 10 questions. Algebraic reasoning and algebra 15, geometry and measurement 15, data and probability 10 questions for a total of 50. Again, if you want to have a look at this or you want to see some of the practice questions on this, that is on my website. I also have links there to our little practice booklet where you took your practice test, so you can go back, review the ones you missed, or when we're doing those practice problems, those links are right here. Okay, a couple of things that we reviewed today in class that I want to quickly look back over. So this, as I've pointed out, is a very common type problem. The concept here, in this case, we have a pool and a deck around it. They're asking us the area of the deck. Well, we find the area of the large rectangle, subtract the small rectangle, whatever they call it, whether they call it a park with a path around it, whether they call it a garden with a flower bed, whether they call it a picture with a frame around it. The concept stays the same. Okay, so we have to find the dimensions of this. They told us that the perimeter of the deck, or the length of the fence, is twice that of the perimeter of the pool. So we can just double the dimensions. That gives us 14 and 8. But then we have to remember to subtract the area of the pool because the pool is not part of the deck. So don't forget about that. Over here, common mistakes I saw was we use this formula, but that's the formula for an entire sphere. We forgot to divide by 2. Very important. Divide that by 2. That gives us 18 pi. And then for this cone right here, that's just straightforward. This is a cone, this is a cone, so just plug it in, plug and play. Put 2 in for R, 9 in for H. Then you get 12. Add those two together, we get 30 pi. Or if you want that in decimal form, 94.25. Remember, vertical angles are congruent. So A and B are congruent, as are these two unlabeled angles. What type of graph is best used to compare parts to a whole? Types of graph, I'll get into those in just a little bit. Parts to a whole would be a pie chart or a circle graph. I want to go back here and look at these angles, something we reviewed in class today. If you already took notes, that's great. If you didn't, or if you weren't here, make sure you're writing this down. Okay. If we have 2 parallel lines, this line that's going through them is called a transversal. This line right here is called a transversal. When we have a transversal through parallel lines, these are pretty easy to work with. Just a few terms that you need to know. On the outside of these 2 parallel lines, we call that the exterior. On the inside, we call that the interior. If angles are on the same side of the transversal, like 2 and 7 are both on the right side of that transversal, call those consecutive. So those would be consecutive exterior, or 3 and 6 would be consecutive interior angles. If they're on opposite sides, they're alternating sides. One on one side, one on the other. So we call those alternate. If they're on opposite sides of the transversal, like 3 and 5. Those would be alternate interior. Think of an example. What would be a pair of alternate exterior angles? 1 and 7, for example, or 2 and 8. If they're in the same place or same position, but on the other line, we call those corresponding. So 1 is top left. On the other line, top left is 5. So 1 and 5 are corresponding angles. Corresponding angles are congruent, and so are alternate. Alternate interior angles are congruent, alternate exterior angles are congruent. Consecutive angles are supplementary, and supplementary means they add to 180 degrees. Complementary means they add to 90 degrees. So here, for example, I gave the example, if this is 130, we know that together these two add to 180, so this is 50. The nice thing about parallel lines and transversals is that there are only two values. Vertical angles, we talked about before, have the same measure, so this must be 50. So that's 130. We said alternate interior angles have the same measure, so this is 50. There, see what I did there? And then this is also 50. This is 130, and this is 130. You might see a problem where they say they don't give you all that information. They just tell you this angle right up here is 130, and angle 5 is 2x minus 10. So then, first thing you could do is just figure out what's the measure of those. Or you could say these two angles have to add to 180 because 1 and 5 are the same. They're corresponding angles. And those two add to 180, so that's 50. So then you can do 2x minus 10 equals 50. Now make sure you're doing that work. Don't just try to rush through it and do it in your head, because I know you guys are smart enough to do that, but we tend to make mistakes. So write it out and then solve it. Plus 10 gives me 2x is equal to 60. Divide by 2 on each side. X is equal to 30. That's the type of problem you might see with a transversal through parallel lines. Okay, and then different type of graphs. A circle graph we talked about could be part to a whole. Many times it's a budget. Okay, this costs this much, this costs this much. Total we have to spend is that much. And so this is how it got split up. Now we had another question. What if we're doing a questionnaire and we want to know whose favorite food is this or that? Can we do that? Should we do that on a bar graph or a pie chart? It depends on how you're displaying it. If you want to know the percentage of students that preferred pepperoni on their pizza, then we'll do a pie chart. If you're just looking at frequency, the number, how many students, then you could show that on a bar graph. You have pepperoni, cheese, sausage, and supreme, and just show a bar graph of how many. So if you're comparing the percentages, how many of them out of all the total students, then you could show that as a pie chart. So a circle graph compares part to whole. A line graph, okay, many times it'll have time to some other quantity. It compares two quantities. On the line graph, remember the x-axis is the independent value. That's the input. The input is the x value, which is the independent value. Now here we have distance versus time. So as the time progresses, we have 1 second. They traveled 10 meters. Then they stood still for another second, then traveled 10 meters per second for the next 3 seconds. Now from here, they traveled back to the start at 40 meters in 1 second. Now doesn't necessarily have to be time. It could be different quantities. Here we have atmospheric pressure. I think I might have said as in 1 or 2 of the classes, as altitude increases, the pressure increases. And thank you to Levi for pointing out that it's the other way around. As altitude increases, the atmospheric pressure decreases. So here's a chart for that. So here we have altitude versus pressure. So a line graph without necessarily having time on there. However, the question on the 8th grade test was she had collected a ton of data points. It didn't say necessarily she collected altitude and pressure, just in general atmospheric pressure values. So if you have a ton of data, that can be displayed in a stem and leaf plot. So on that one, I would have accepted either one of those answers. Okay, a bar graph. A bar graph compares specific items or groups. So this many kids liked soccer, this many like basketball, this many tennis, and so on. Okay, this is not a progression. It doesn't go, okay, as we progress this way, it goes from soccer, it morphs into basketball, becomes tennis, and then the further it goes on, this is not a progression. These are different items, and so there are no check marks down here. We're just finding quantities of these. We compare specific items or groups. In a histogram, there seems to be the most confusion with histograms. Okay, a histogram displays the frequency of intervals. Okay, very important, we have intervals. So here notice from 0 to 10, and then seamlessly goes over to 10 to 20. Or it depends on how this is set up. It might be set up from 0 to 10, and then 11 to 20, and then 21 to 30. Depending on what we're measuring, how it's set up. This I actually think is not correct as it is, because if they asked you 10 points, where would you add that one to? Well, that could be here or there. So this should be 11, this should be 21, 31, 41. But you won't always have the intervals indicated as they are down there. Sometimes you could see a histogram like this. Notice this is still an interval. It goes from 24 to 32. So ends here. Anything below 32 is this way. Anything 32 and above is that way. So this is still an interval from 24 to 32. So don't be confused if they haven't listed the interval the way it is up here. So here down here we have our groups from 24 to 32 is the interval. That's for the histogram. And that's all we have for today. Make sure you're going back over everything that you missed on your practice test to check to see where the gaps are, what we need to make up. I will see you tomorrow.